Okay, so we're going to look at exponential and log integrals today. So take a second and write this down. If you have the integral of e to the x, that is equal to just e to the x plus c. If we have the integral of 1 over something, or 1 over x, that's just going to be ln x plus our constant. It's not always going to be obviously e to the x or 1 over x. So we'll see what we do when this is something more comprehensive than just x. Okay, so let's start with some e to the x's. When you're doing the integral and you have an e to the x in the problem, whatever's in the exponent is going to be u. We're doing u substitution here. So we have to remember some stuff with that. Okay, so whenever I have an e to the x, whatever is in my exponent is what is equal to u. I take the derivative of this, so we're just remembering u substitution here, and I get 3x squared. Now, this part out front of that e to the x cubed is going to get moved in front of the integral because that has nothing to do with u. And then I'm going to divide that by du. So du is 3x squared. And then I leave this part in the integral. I'm going to simplify this down. That simplifies to 2/3. And then I'm going to substitute in u for this because I said u equals x cubed. So now it's du. I do the antiderivative here, which we saw on the last slide is just e to the u plus c. And now I substitute back in what I said u was, x cubed. Okay. Okay, so we have another example of this. We have our e with to the power of 5x plus 1. So this is what my u is going to be. I take the derivative. Back to my integral. Whatever is not a part of that gets moved in front of the integral, and I divide that by du, which we found was 5. So I simplify this if I need to, but it does not need to be simplified. So I just leave it as 3/5. I'm going to substitute in u for that exponent because that's what we said u is equal to over here. Then I do the antiderivative, which is just e to the u plus c. And then I sub in the 5x plus 1. Okay. Okay, let's try one more of these. So I have my e to the x squared plus 2x. This is what I'm going to say u equals to. Do the derivative. Back to my integral. This part gets moved to the front of the integral, and I divide by du. I leave this inside of my integral. In this denominator, I can GCF out of 2. So these get canceled out, so I have 1/2 integral, and then I substitute in u for that exponent. Now I do the antiderivative, and then I substitute back in what I said u was. Okay. So now let's try some examples here. What we wrote down from that note page was that the integral 1 over x is equal to ln x. So for this, whatever is in the denominator is going to be u. So whatever is in the denominator is u. So I do du, which is just 1. I'm going to move out that numerator, and I'm just going to leave 1 over x inside the integral. I divide this by du, which is 1. So 4 divided by 1 is 4. I substitute in u here. because I said x was u. When I do the antiderivative of this, I get ln u, and of course plus c. Then I just sub back in that x for u, and there is the antiderivative. Okay, so we have another fraction one. So whatever is in the denominator is u. I take the derivative, that's negative 2x. Coming back to the problem, I'm going to move out my numerator out front of the integral, leaving 1 over this 6 minus x squared dx. I divide this 2x by du, which is negative 2x. This is going to simplify to negative 1. I substitute in u here. The integral of 1 over u is ln u plus c. So then I substitute back in 6 minus x squared plus c. Okay, let's try one more. Okay, so another fraction one. The denominator is u. I do the derivative, which is 9x squared. I GCF out that numerator in front of the integral. Bring it out in front. I shouldn't say GCF. You bring it out in front. Divide by du. And I have 1 over 3x cubed minus 1. This simplifies to negative 5/9. I'm going to sub in u here. So the integral of 1 over u is ln u plus c. And then I just sub in 3x cubed minus 1 for u. And there is the antiderivative. And that's it.